This unit is an introduction to functions. Functions are the building block for all mathematical models in algebra and beyond. A function is a relationship between sets of numbers. Often, functions have a rule that help predict an output from a given input, but not all functions have rules. If you think back to elementary school, you learned about a function machine, or an input-output machine. We will use that analogy again in this unit. Let's first consider what a function is by looking at some graphs. The graphs on the left all represent functions, while the ones on the right do not. Study them for a minute. Pause the video if necessary, and try to come up with a general rule for identifying a function from a graph. Now, based on your observations, decide which of the graphs on this slide represent functions. Can you describe how you are making your decision? Now watch as the function graphs are highlighted. Were you correct? Let's formally define a function. First, we will consider a relation. A relation is any set of ordered pairs. A relation can be represented by a list of ordered pairs, by a table, by a graph, or by a mapping diagram. We will look in more detail at each one of these representations later in this video and tomorrow in class. A function is a relation in which each input is paired with one and only one output. A function, therefore, is predictable. If you know what goes into the function, you can predict what comes out. Every function is a relation, but not every relation is a function. We will now look at functions from each of their different representations. We started the lesson looking at graphs of functions and non-functions, which we now know are called relations. The graph of a function passes the vertical line test. This means that if you can pass a vertical line through any point of the graph and only hit one point on that graph, then it is a function. Watch as the red vertical line passes through the graphs on the left. Notice how at no time does it hit more than one point on the graph. The graph on the right, on the other hand, fails the vertical line test. As you can see, a vertical line hits 3 points on the graph. When looking at the table of a relation, we want to consider the input side of the table, or the x values. If the input values are all unique, in other words, if they don't repeat, the table represents a function. The tables on the left all represent functions because none of their inputs repeat. Here again is the idea of being predictable. Consider the third table on the left. If we input the value -2 into this function, we know the output will be 7. It is okay that 7 appears multiple times on the output side. However, look at the first table on the right. If we input -2 into this relation, we don't know if we will get -2 or -3 on the output side. It is not predictable. For what values is the second table on the right not predictable? If you said input values 5 and 4, you are correct. For the input value of 5, we can either get -2 or 2. For an input value of 4, we get -1 or 1. A mapping diagram is a final way to represent a relation. The diagram maps an input to an output using arrows. In the first diagram on the left, you can see the 5 maps to 2, the 7 to 0, the 8 to 1, and the 10 to 2. Again, it is predictable. Every input maps to one and only one output, as indicated by the single arrow coming from each input. How can you tell the diagram on the right is not a function? Notice on the input side that the 1 has two arrows coming from it. The 1 maps to an output of 5 and an output of 3. It is not predictable. If we input 1, we don't know for sure what we are getting out. You can tell a mapping diagram does not represent a function when you have multiple arrows coming from one or more inputs. This concludes our introduction to functions. Tomorrow in class we will practice identifying functions from graphs, tables, and mapping diagrams, and we will work on representing functions in all three ways.